Okay, so let's talk a little bit about deriving units. I actually find it very interesting that we don't need very many base units at all in order to derive all the units for all the different things that we might want to measure. So let's go through a little thought experiment here about why or how we might go about doing that. So let's start with a base unit here. Here we have the one for length. We have a meter, which I'm going to represent as this line right here. Okay. And we might abbreviate that with a lowercase m. Now, that's a unit of length. But let's think about, what if I wanted to know the area of something, like if I wanted to know the area inside of a pen or something like that. Well, one thing I could do is I could take this length and I could picture just making a square out of it, right? Where every one of the lengths was 1 meter long. And in that case, you can see we'd have the area equal to the width of this square, or A, multiplied by the length of the square, or B. Now if we put in our values for A and B, and we're going to see here we have B being 1 meter and A being 1 meter, okay? And I'm going to replace those in there. I'm going to do a substitution. I'm going to put in their values, and you're going to notice I'm going to write the quantity, 1, and then a space, and then I'm going to give it a unit, meter. And I'm going to do the same here. And in other math classes, you often will see these units, like a pure math class, these units are omitted, but it's never appropriate in science or engineering to do that. Okay, these aren't just pure numbers, they're quantities and they have a unit, so you should get used to doing that. After that, when I do this multiplication, you can see I have 1 times 1, or 1 squared, which is also 1. And I'm also going to carry forward these units, and I'm going to do the same mathematical operation. I'm going to take this meter, I'm going to multiply it by a meter, and I'm going to have a meter squared, or a square meter. And this is now a new unit that I have derived for area, and it has a very specific value. Here we can extend this up to volume. So you can imagine that I have a cube. Each one of these edges is 1 meter long. The volume of that cube is going to be A times B times C. And I'm going to do the exact same thing. I'm going to remember to always have my number and unit. I'm going to multiply all three of those together. I'm going to have 1 cubed, or 1. And then here I'm going to have a cubed meter. And now I've derived a whole new unit, which I can call a cubic meter.